Okay, I'm happy to have you in class today. Welcome to our chemistry class. If this is the first time you're viewing seeing this video from our channel, please do well to subscribe. We take lectures on physics, chemistry, and mathematics. The Supernovas TV. Okay. Now we're going to explain physical and chemical changes in chemistry. That is the changes that matter undergo. In our previous class, okay, we looked at changes in matter as regards from solid to liquid and to gases. In this class, we're given a general the general features of physical and chemical changes, and then we'll also look at compounds and mixtures. Okay, so we have physical and chemical changes. Chemical physical changes, as we know, are changes, okay, that are temporary. Okay, you see, physical changes are temporary. Okay, for instance, as we looked at water the last time, um, heating ice, okay, to have water, and then heating water to have steam or vapor. Those are temporary changes because we can reverse the processes. All right. So physical changes are temporary. Okay. And in a physical change, no new substance is formed. No new substance formed. That is another feature of a physical change. Also, you know that it is the same quantity we are actually moving from one phase to another phase. There is no new substance that is formed in the process. Okay, we can also say in physical change, the physical change is easily reversible. Easily reversible. Okay, so when the temperature goes up or when the temperature comes down, it depends. Okay, the process can be reversed. Okay, that's the features, some of the features of physical change. And also you can say no great change, heat change involved. Okay, no great heat changes. Okay, involved. We do not need great heat changes in physical change. Now let's look at chemical change. Okay, a chemical change, for instance, rusting of iron is a chemical change. Burning or combustion of wood is a chemical change. Okay, now these are permanent changes. Okay, chemical change, we say they are what? Permanent. Okay, now, for a chemical change also, a new substance is formed. Okay, when rust is a an entirely new substance from metallic object. Okay, we can also look at chemical change in rotting of tobacco leaves. Okay, in lighting a match, that's a chemical change. Okay, the matchstick burns. Okay, in fermentation reactions, those are all chemical changes. Fermentation, okay, is a chemical change. Precipitation, they are chemical changes that cannot be reversed. Okay, so we say they are permanent. Okay, we say new substances are formed. New substances are formed. Okay, and then we also say that they are not easily reversed. They are not easily what reversible. Okay, and then it needs great heat changes. Okay, great heat changes involved. Great heat changes involved. I hope you can see this. Great heat changes involved. Now let's look at some examples of physical and chemical changes. I've mentioned examples before. We have melting, we have freezing, we have dissolution of freezing of ice cream, melting of ice. You understand? Okay, dissolution of salts, common salts in water. Okay, sublimation. These are all examples of physical changes. Okay, sublimation, we have boiling. Okay, these are all examples of physical change. What about chemical changes? Okay, we have combustion. Okay, we have combustion, we have fermentation of ethanol. Okay, we have fermentation, we have roasting of iron. Okay, we have precipitation. We also have dissolution of metals in mineral acids. Okay, for instance, dissolve metals like calcium, okay, in sodium hydroxide. Okay, these are chemical changes. Even formation of slick lime or lime water, they are all what? Chemical changes. Okay, dissolving that may not contain here. Dissolving metals in mineral acids. Okay, those are all examples of what? Chemical changes. Combustion or burning of wood, it gives us an entirely new substance. Charcoal or ash, those are all new substances. Rusting of iron, fermentation of alcohol, okay, rotting of tobacco leaves, okay, used in the manufacture of cigarette and in the tobacco company. Okay, so we have many others. Okay, fermentation, okay, making of yogurt. Okay, we need a fermentation reaction there. Okay, and in baking, all many industries, we make use of chemical changes too. Now let's look at compounds and mixtures. From physical and chemical changes, we can see that we can go from physical changes, we can get mixtures where substances mix together. We can also use that to explain what happens in mixtures, and then also compounds using chemical changes. So the next thing we're looking at is compounds and mixtures. We already know elements. You know what elements are? Elements are simple, it's very simple substances or chemical substances that cannot be separated by an ordinary chemical process. Okay, we have examples of elements, hydrogen, nitrogen, and all that. Okay, we have non-metals, and we also have what? Metals. I think we'll look at that in another class. We'll look at elements, or if we still have time, we'll look at that. But let's just go quickly to compounds and mixtures. Compounds and mixtures. I hope you follow in the class. Okay, compounds and mixtures. Now, compounds are substances, okay, formed when two or more component elements combine chemically together. Okay, so they must combine chemically together. I have to give some space. So I'll write that of mixtures when they combine chemically together. Okay, now example of a compound. Let's look at the example of a compound. We have sodium hydroxide. So we'll use this to explain. Sodium hydroxide. This is a base. Sodium hydroxide has a formula of NaOH. Okay, I hope you're following. Now, compounds are usually formed by chemical changes. That's why we say they're substances formed when two or more component elements, okay, combine chemically together. Take note, compounds are formed by chemical changes or chemical process. They cannot be separated by physical means. Okay, they are usually homogeneous. Compounds are usually what? Homogeneous. They have to be in the same phase of combination. That's what we mean by homogeneous. Okay, compounds are always represented using a chemical formula. Compounds are usually represented using a chemical formula. Take note of that. Okay. Also, if we look at water, also water is H2O. Water is a compound because it has a formula. Now, apart from that, compounds, okay, have different properties from the component elements that combine to make to form the compound. Okay, properties of hydrogen and oxygen are different from properties of water. Okay, so we say they have different properties from what? The component elements. Remember, I say compounds cannot be separated by physical means because they are actually formed by chemical process. And also, don't forget that the elements, component elements in a compound actually combine in a fixed ratio. Okay, for every 1 mole of water, we need 2 moles of what? Hydrogen to 1 mole of what? Oxygen. Okay, so that is 2:1. Okay, so they're combined in fixed what ratio. Now over to mixtures. What are mixtures? Mixtures, you can say they are formed, okay, when two or more constituents, okay, combine together and can be separated by physical means. Okay, okay, mixtures made up of two or more constituents. Okay, that can be separated by what? Physical method. Now, what we mean here is that these constituents, they can be elements, they can just, okay, but they combine in a way such that they can be separated by physical methods, which means combination or formation of mixtures involves a physical change. Okay, we can easily separate the constituents. Okay, the example we say that air is a mixture of gases. Okay, air is an example of a mixture. In mixtures, there is no formula. Okay, the constituents combine in any proportion, no fixed proportion. Okay, no fixed ratio of what combination. Okay, the properties of a mixture are actually the sum, or is the sum of the properties of all the constituents that make up that mixture. Okay, now mixture can be homogeneous, it can also be heterogeneous, which means it can exist in a uniform phase, it can exist in non-uniform phase. Okay, okay, we also have other examples. Okay, we have crude oil, we have blood, we have urine, we have brass, we have bronze. They are examples of what? Mixtures. We have local wine. We have many examples of mixtures. Okay, I hope you understand the explanation. In the next class, we'll be looking at separation of mixtures. Since we say mixtures can be formed by physical methods, therefore we have techniques to separate different mixtures. Okay, I hope you enjoyed this class. Do not forget to subscribe to our channel. I'll see you in the next class. Bye.